welcome to the 4th episode of Uncle Ron's Academy. Today we are going to be doing some chemistry experiments involving acids and bases. What exactly are acids and bases? Acids and bases are two different groups of chemicals, each of which have certain properties in common. One of the things that is interesting about acids and bases is that there are many natural coloring agents, dyes, that will change different colors depending upon the level of acid and base. We call this the pH rating system. One of the most popular pH rating system indicators is something known as pH paper. This is what pH paper looks like. It looks sort of like this orangey color. pH stands for the power of hydrogen, and it changes 14 different colors depending upon whether it touches an acid or base. The stronger the acid, the redder it gets. The stronger the base, the bluer it gets. We have over here in these 6 beakers, we have 6 different liquids. We have in beaker number 1 hydrochloric acid, a very strong acid. Beaker number 2 contains vinegar, a rather weak acid. Beaker number 3 is ordinary water. Beaker 4 contains a mixture of baking soda with some water. Beaker number 5 is something nicknamed lime water. Its actual name is calcium hydroxide. It is used to fertilize gardens. And beaker number 5 is ammonia, which is used in cleaning. Each of these has a different pH. Some of them are acidic, some of them are basic, and some of them are neutral. As I put in a piece of pH paper, you will notice how the color changes. So first we will do hydrochloric acid. You see the color the way it is, and now you see it has turned a bright pink. That is a sign that there is an acid here. The next one, vinegar, is a weak acid. We put in a piece of pH paper, and this time doesn't turn so pink. It turns sort of like a dull pink. Not exactly as bright as the hydrochloric acid. Next we come to ordinary water. We put in a piece of pH paper into water, and as you might have predicted, it doesn't really change much of a color at all. It sort of is turning slightly yellowish. A little hard to see. Next we come to baking soda. Baking soda is no longer in the acid range, it is in the alkali or basic range, and this time we get a light green color. This is followed by a stronger base, calcium hydroxide, or otherwise known as lime water, and this one gives us a slightly darker green. And last but not least, we have ammonia, which is a much stronger base, and here it should be close to a greenish blue, or this is even a darkish blue color, stronger than I anticipated. Another way of identifying acids and bases is to use something that you can find in your vegetable store known as red cabbage. So if you buy a head of red cabbage and boil it and extract the liquid, it's kind of healthy cabbage soup. But it can also be used as an acid-base indicator. By pouring it into different chemicals, we can see how the red cabbage changes color. With the hydrochloric acid, nice reddish pink color. With the vinegar, light pink. With the water, sort of stays the same, a little purplish. With the baking soda, kind of a greenish blue. With the lime water, a little more blue, and with the ammonia, a dark green. Another way of indicating acids and bases is if you go to Petco and you get something known as pH indicator solution. This contains a chemical known as Firestone-Morrill blue. Firestone-Morrill blue, again, will change different colors depending upon what chemical you put in it. So here are 6 test tubes with the 6 different liquids. And if we put in a few drops, this one turns orange. It is an acid. This one sort of turns greenish yellow. There is the water, almost brown. Here we have a sort of dark muddy green. Here we have a dark yellow. And the last one, we have a regular yellow color. Again, all this is dependent upon the strength of the acid and base. And now for the last demonstration, it's kind of fun to mix acids and bases together because by doing that, a chemical reaction occurs. It creates the gas known as carbon dioxide, and usually there is something else that is involved. So here is a little bit of vinegar, a weak acid, here is some baking soda, a weak base, and we put them together and you get the old familiar bubbling reaction, making carbon dioxide bubbles and going over the side and making a mess. How much fun is that? You could actually do the same thing with the beakers of color that we've done. Mix an acid with the base and see what happens. And you get all different kinds of different colors that show up. There is the purple. There is the dark purple. There is the red, showing that this is still an acid. Bubbles are forming, carbon dioxide bubbles are forming, and you are beginning to neutralize the acid with the base. And that's all for this week. Bye.